Welcome to Weekend Academy. We are going to discuss some of the practice problems in chemistry. The first one, question number 1. Which among the following is the least basic in nature? We are given 4 amine compounds. Out of this, we are going to compare the basic strength of these 4 compounds and decide which among them is the least basic. So, basic strength of an amine is very much decided by the availability of lone pair of electron on nitrogen atom. If lone pair of electron is more available for bond formation, that compound is more basic. If less available, then it is less basic. So the availability of lone pair of electron on the nitrogen atom can be decided by these two effects mostly. One is plus I effect, the other one is not plus M effect. Plus I effect, directly proportional to the strength. But whereas plus M effect inversely proportional. It means if plus M effect is there, the basic strength is reduced. Here we should understand what is plus I effect. Plus I effect, electron donating ability. Electron donating ability to the nitrogen atom. Normally the alkyl groups can donate electron or donate electron cloud to the nitrogen atom and thereby increase the basic strength. But whereas plus M effect means the ability to withdraw the electron pair from the nitrogen atom into the benzene ring and extend the resonance inside the benzene ring. For the purpose of extending the resonance of the benzene ring, the benzene ring, what does it do? Pull the electron pair from the nitrogen atom and form a double bond here. So and then double bond shifts here, there, and giving rise to different resonance structures. So this phenomenon is called plus M effect. When the electron cloud is drawn out of the nitrogen cannot perform the electron donating ability. In other words, its basicity decreases very much. Okay, now we compare these 4 compounds. 1. The N-methyl aniline. In the N-methyl aniline, plus I effect is there due to the presence of methyl group, and due to the presence of phenyl group, the electron pair is drawn. Plus M effect there. Plus M effect does this way decreases the electron cloud, but whereas plus I effect, what happened? No, effect increases the electron cloud, but however M is dominant over the I. It is more powerful. As a result of this, the net effect is decreased basic strength. Now we compare this compound C. Here N dimethyl aniline. Here 2 plus effect. Here is a plus I effect. There is one more plus I effect, but one strong minus, electron withdrawing effect, that is called a plus M effect. Okay, when we compare C with A, C is stronger than A. But however, due to the presence of plus M effect, both are weak bases. Okay, now come to this compound A, aniline. In this, only plus M is there. It is because of the plus M, the basic strength is very much decreased. So this is still weaker than A. So B is the least basic among the 3. Now we have to come to the 4th one. In this case, this is not at all an aryl amine. It is alkyl amine, benzyl amine. Because the benzene ring is not directly connected to the nitrogen, therefore no plus M effect. Only plus I effect is there. So this presence of plus I effect increases the basic strength, and this is the most basic among the 4. So D is the strongest base. So this is the order. The question is, which is the least basic? Least basic is asked. So beyond doubt, B is the least basic. Okay, to sum up here, among the four, compound B has only plus M effect, which reduces the basic strength. Compound D only plus I effect, which increases the basic strength. So D is the most basic, B is the least basic. Shall we move on to the next one? Here, standard electrode potential E naught for Fe3 plus into Fe2 plus is asked. Here there are three such reactions. One is Fe3 plus is converted into Fe, one reaction. Then another one is Fe2 plus is into Fe. The third one is Fe3 plus into Fe2 plus. It is so simple to understand here. 3 to 0, 3 to 2, and then 2 to 0. In other words, sum of this and this equal to this one. Okay, and one more point to understand here, the first reaction involves addition of 3 electrons, but the data given here is only for 1 electron. So what do we do here? We will go to multiply this data by 3 with 3. But here involves 2 electron. 2 electrons have to be added to Fe2 plus, only then we get Fe0. Therefore, this has to be multiplied with 2. Okay. Now, if you substitute, what do we do here? Find the value of this minus this. We get this. Okay. Now, what to write here? Minus 0.04 into 3 minus here minus 0.44 into 2. You will be getting the answer. This is minus 0.12 here plus minus into minus plus. Here there is one minus, no, plus 0.88. Finally, we have 0.76 volt. Okay, where is the answer? Here is the answer. It is so simple. Two data given on the third one is asked. Here Fe3 plus into Fe0 and Fe3 plus into Fe2 plus Fe2 plus into Fe0. Here the value into 3 because there are 3 electrons involved here. Here 2 electrons involved here. So into 2. From this minus this one, we get this one. This is the answer. So it is simple. We move on to the next one. Here you are given 4 set of formula compounds and their respective geometry. List A, PCl5, bromine pentafluoride, boron tetrafluoride, tetracyanonickelate 2 minus. These are the 4 compounds. Their geometry is given on the list 2. We will have to find out the correct geometry and match them. See, first PCl5 we shall take. Phosphorus belongs to the 15th group. It has valence electron 5. 5 fluorine atoms are connected to. So all the valence electrons are involved. It has 5 bonds. 5 bonds means sp3d. sp3d. S1 bond, P3D1, altogether 5. sp3d means trigonal bipyramid. It is trigonal bipyramid. So simple. Phosphorus 5 valence electron, 5 atoms are connected. So 5 bonds are there. 5 means sp3d, 5 tetragonal bipyramid. Next, boron pentafluoride. Bromine 17th group. There are 7 electrons. Out of the 7 electrons, 5 electrons are used. Then we have 1 lone pair. 2 electrons are left to know. The 1 lone pair with 5. Altogether 6. So 6 means sp3 D2, sp3 D2 octahedral. But one lone pair is there, no. The how to draw here, no. This is a octahedral. 1, 2, 3, 4 bonds. Okay. And one bond is here. And one lone pair of electron is here. So this is square pyramidal. Which one? Boron. Square pyramidal. Where is it? Here is square pyramidal. So A is linked to 4. B is connected to 3. Sorry. Boron tetrafluoride. Boron has valence electrons 3 and 1 electron is extra. Therefore, 4 electrons are there in the boron atom. 4 atoms are connected. Therefore, no lone pair. So, totally 4 bonds are there. 4 means sp3. sp3, where is it? sp3 means tetrahedral. C1. sp3 tetrahedral. Now we have the last chance. The last one supposed to be square planar. We will finalize. Nickel 3d8. 3d8. Those 3d8 electrons, how they are linked. If you want to understand, 1, 2, 3, 4, and 5. All the 8 electrons pushed inside and paired up due to the powerful ligand Cn. And we have 1, 2, 3. It takes up this 1, 2, 3, 4. This is called DSP2. So 1 d orbital, 1 s orbital, 2 p orbitals, altogether DSP2 combination. DSP2 means a square planar. Here, this type of hybridization is due to the powerful ligand Cn minus, which push the electron to pair up and resulting to the formation of square planar. Square planar is true. So this is how we are matching the compounds with their respective geometry using the hybridization concept. With that, we are concluding the video, and we will meet again in the next video with some more problems for practice. Thank you.